Hi folks, Mr. Long here. I'm going to do a quick screencast on how we graph quadratics in factored form. So I guess the first thing we need to think about is, what does factored form mean? Well, factored form for algebra means the exact thing as factored form for numbers. So I could have, here's some numbers I could have, 2 plus 4. Okay, that might call that standard form or sum form. Now, that also equals 2 multiplied by 3. Okay, 2 multiplied by 3. This would be the factored form of 6, or a factored form. Factored form of 6, right? Because 2 times 3 is 6. This would be like a sum form or a standard form because we're adding. So they're both 6. They have just different ways of being represented. One's adding and one's multiplying. Okay, so it's the same thing for algebra. So let's just do a quick review of the forms that we've done. So we've been working a fair bit so far with what's called standard form of quadratics, ax squared plus bx plus c. And the only thing we get out of this is the y-intercept c and the direction of opening, a. So for example, if a is less than 0 and c was greater than 0, like this, our graph might look like that. Okay? That's about all we can know. So the direction of opening, a tells us that, and the y-intercept, c. Okay? So there is, if a was less than 0 and it was a frowning parabola, it would look like so. Vertex form, what information do we have here? Well, we have the 0 square. Okay, the 0 square. X equals p causes the square to be 0, because if I replace x with p, I get p minus p. A tells us the direction of opening, smiling or frowning. And q is the y value at the vertex. Okay, so the x vertex is p, and the y value of the vertex is q. So for example, if I had a value of p right here, a value of q right here, and I also knew that a was greater than 0, the parabola would be smiling, and that would be the vertex. Now, I can also work out the y-intercept here by just substituting in x equals 0. Okay, so that's vertex form or transformation form of a parabola. Standard form, where I'm adding all the terms. Vertex form, where I work with the 0 square. Finally, factored form, which we haven't worked with yet. Factors means multiplication, and it makes sense. That's a factor, so is a, and that's a factor, okay? So the big idea is, what makes this factor 0? Because let's think about this for a second. If this is worth 0, then 0 multiplied by a multiplied by this factor will be 0, because 0 times anything is 0. So if the right side of the equation is 0, the left side also has to be 0. And where does y equal 0? All along the x-axis. Okay, so if the right side is 0, has 0 in any of the factors, the whole right side is 0. If the whole right side is 0, then the left side is also 0. Okay, so here's what we do. If, for example, a was less than 0, it would be frowning, right? Be frowning. And what would make this bracket worth 0? Well, x minus z1 would equal 0. Add z1 to both sides, and x would be equal to z1. That makes that first bracket 0. Similarly, x equals z2 will make the second bracket 0. Why do I call it z1 and z2? Well, we often call them zeros or x-intercepts. So that's the way I put it in the equation. Okay, so how would I graph this? If a was less than 0 and x was z1 or x was z2, it would look just like this. So I would have an x-intercept of z1, I would have an x-intercept of z2, and if a happened to be negative, the graph would be frowning. Okay, so it would look like so. Okay, so we can see that factored form gives us x-intercepts, vertex form gives us vertex, standard form gives us y-intercept. Okay, So let's practice sketching a couple of these in what we call factored form. Okay, so the goal here, folks, is to make, and we're going to change that one to +3. So what we're going to do here is we're going to sketch this to find the x-intercepts. So if I look at this, I'm just going to do this. What happens if that factor becomes 0? Like, how would I make x plus 3 equal to 0? Well, x plus 3 would equal 0. So x would equal -3, right? I have to subtract 3 from both sides. I can call that z1 equals -3. Okay, or a 0 is -3. So what happens if this x is -3? Well, I get -3 plus 3. That's 0. 0 multiplied by 2 is 0. These two are both 0 now. I multiply by that. It doesn't matter what x is. I'm going to get 0. If the right side is 0, the left side is 0. If the left side is 0, I'm at y equals 0. 0 up and 0 down. I'm on the x-axis. Those are x-intercepts, or zeros. Okay, for the second one, x minus 7 equals 0. X equals 7, and I can write that as z2 equals 7. Let's quickly make a sketch now. So I have one x-intercept at -3. I have another x-intercept at 7. And since the a value here is positive, the graph is smiling. Okay, the graph is smiling. So it would look like so. Now what's really nice about this is, I can solve inequalities really easily. What if I said the range was positive? What's the domain? The range was positive. What's the domain? If the range is positive, then that's the part of the graph I'm interested in. And then I would have to figure out what x values are associated with that. Okay, let's do another one right here. Y equals -3x times x minus 4. Okay, so let's see. Oh, this is kind of a weird one, isn't it? So what you might want to do initially, you don't have to do this, but -3, and that x is by itself, so I could write x minus 0, x minus 4. So that's going to help us, I think, to get our x-intercepts. So this bracket will be 0 if x equals 0, 0 minus 0, 0. And then x minus 4 is 0 if we have x equals 4. So that would mean z1 is 0, z2 is 4. And by the way, the a value is -3, so the graph is frowning. Okay, let's make a sketch of this. So x equals 0 is an x-intercept. That's right here. And then 4 is an x-intercept. Okay, so I have that. And then I just graph. Oh, it's a frown. So I know it goes like this and like this. So if I said the range is positive, what is the domain? Well, that would mean if the range is positive, I only want y values above the x-axis. So the x values that would satisfy that range, like the domain that would correspond to that, would be between 0 and 4. I think you get the idea. So just going back to this right here, this x right here that we see, what I did is I just took it because it's a factor, and any factor can be put in a bracket. Like I could put a bracket around the -3, I can put a bracket around the x, it doesn't matter. Usually numbers, which we call coefficients when they multiply into variables, there's no bracket around them. But I can put the bracket around this. Okay, folks, so that's how you graph in factored form. In the next video, you're going to learn to solve inequalities in factored form.